Ben Wishovich, next speaker.
Ah. Can everyone hear me all right? I'm mostly asking the online people because I'm pretty sure y'all can hear me. Pretty sure.
What did you say?
I'm going to assume that we're good. First off, apologies, right? Tim and I just rode a couple 100 kilometers on the bike to get here from Rust Week, so he's put me through it a little, but hopefully it'll work out. I absolutely know no German, so if anybody gets confused, feel free to stop and then someone can help me. I'm not going to be saying any German, so that'll work out, maybe. But yeah, I've been a web developer for, this slide says 4 years. Depending on how you count it, it's between 4 and 8. I'm one of the core maintainers of Leptos, and Leptos has been around for almost 4 years now, so we're coming along nicely. When I first joined, the core of it was just a tiny little state-based UI library, and since then we've added a whole ton of other features that I hope you all get to experience. So, yeah, like I said, 40. I always have to shout out Greg. Greg is the other co-maintainer, the founder of Leptos. You may or may not have seen some of his videos. He's got some more on YouTube, and he gave a talk in England earlier this year. But he got me into it, and he's helped build our community a whole lot. So shout out for him. I'm going to talk to you today a little bit about WebAssembly on the web and how it came to be and how we got to this point. And then I'm going to try to tempt you to try it, try to tempt you to do Rust on the web. You know, a few people, no. I'm going to, Goats, yeah, okay. The other guy. I am a pretty huge proponent of using Rust on the web. I think it's absolutely production ready. I am going to show you a whole bunch of production users that are using it in a second, and I've learned of a few more that are not even in here that we might talk about briefly. So what is Leptos, right? Leptos, as the previous presenter mentioned, is a full-stack web framework. It basically means that you can build both the UI that browsers will see and some form of data backend with Leptos. That comes in a lot of shapes and sizes and forms, but we've got most of them, so it works out. This might need Tim's help a little bit here, but here are a few, this here is a link. So here is a few examples of sites that were built with Leptos. If you want to click that link there, it should open a page for it. So different things. The reason I put these in here mostly is to say, we don't have to watch that. I mean, you can if you want to. I don't know a ton about Pattern, but, you know. They built some of their dashboard in Leptos. Really, as I was saying, the point that they're in here is that you can build almost any kind of app. This is a fairly regular, traditional tech startup loading marketing page, right? We can keep going. There's not much to talk about if you're used to it. There are a few more of these. Rust Adventure, if you've seen Chris Biscardi's YouTube videos. He's a big Rust educator. He's got a lot of those. His whole video platform is built with Leptos and Rust. We'd love to have him. I think it works pretty well and looks pretty good, which is about what we need, right? Let's keep going. Rusty Tube. We don't have to load this one, but this is someone's alternative YouTube front end, whose name I forget, but neat. Check it out later if you're interested. The California Beach Volleyball Association. Very oddly specific, I know, but it can work for anything, right? Whether you should is a different question, but it can. So I think for the web at least, we started with this dream that you could use almost any language on the server to distribute websites, right? To build websites from COBOL, JS, Rust, whatever. And I think some of the recent movement especially has been away from that and a little bit more towards one language or two languages, depending on that. So I want to talk a little bit about how web development has flowed over the last 40 years, I suppose. No, 30 years, roughly. Some of which I was alive, some of which I was not. So fact check me. In the back in the earliest thing, back in your PHP days, we all had our multi-page apps. They were fairly simple things. You navigate to the page, you talk to the server, the server sends back your HTML, CSS, and you just repeat that cycle forever, right? This is the traditional server rendered app. It still exists in some places. You can also build that with Leptos if that's your preference. MPA plus jQuery, right? So then some developers come up with the idea, hey, what if we had some client-side interactivity? What if we didn't have to go to the server if they click a button or something like that? What if we just put some more JS on the browser? As computers got faster, this became a bit more of an option, and now we can kind of short-circuit that process and added a lot more JS, but it was nice, right? And that kind of progressed. I'm missing one. That's okay. The one that I'm missing here is SPAs, or single page apps. So from this, basically we had the idea, hey, what if we basically cut out this whole thing here and we just send everything down as JavaScript, HTML, and CSS, and then your browser will just talk to itself for the most part, right? And this is kind of tied to when React came to be back in 2008-ish, I think, is, hey, we can do this. It's simpler. We don't have to worry about where the data lives or if we're sending it from the server to the browser or whatever. It's all in the browser, basically, and maybe occasionally we'll get some stuff here. Functionally, it's one of the simpler methods of building an app, and you can absolutely do that. Our docs start with that. But recently, it certainly seems like we're moving back towards server-side rendering with hydration. So unlike the previous server-side rendering thing, we send down HTML, CSS, and a bunch of JavaScript here from the server, right? So it's all rendered here. In client-side rendering, which is this one, in client-side rendering, we basically send almost nothing except JS from here. And in the browser itself, we load the pages. In server-side rendering, we load the pages on the server and then also send down some JavaScript to help with interactivity. And then when you need data or when you need to do updates, right, you send some JSON to the server and you get some JSON back. And I'm sure we've all seen plenty of JSON responses from servers. And it works pretty well when you care about things like how long until you see the page, right? So what is Leptos doing here? Well, we started with the full-stack rendering, server-side rendering with hydration, right? But instead of JavaScript, we have a little bit of JavaScript, but mostly instead of JavaScript now, we're going to send down some WebAssembly. You're going to have WebAssembly handling page updates somewhat, and we can still send JSON back and forth, right? And that gives you a little bit of flexibility. It gives you a fair amount less JavaScript over time. And it gives you a lot of flexibility because unlike JavaScript, which some things will transpile into, there are a lot of languages that will compile to WebAssembly that you can use here. I mean, we do a Rust framework, but I know there's a C one, I know there's JavaScript, there's Python, C#, you name it. It's really helped expand the possibilities in this system to languages that aren't natively interpreted by the browser. So not JS, right? And you can kind of see what that looks like in the network tab here. This is one of our examples. It is the Hacker News example. You can kind of see this is a client-side rendering, it looks like. Hold on, let me check here, because I've forgotten which one I put in here. Yeah, so this is server-side rendering, right? It starts loading the data as soon as it gets the request here. And that really makes your life less painful. So I sometimes do a live demo at this point, but mostly I'm just going to go through it because you already saw a lot of what that looks like from Dioxys and from you. They're all somewhat similar in their dynamics, but I'll point out some of the differences, right? So we have components. If you've done React components, this should look pretty similar. It's all based around functions. The functions take props that you can input. And we actually have a JSX-ish. I tend to call it RSX, but Dioxys also calls it RSX. So I'll have to fight them for it later. But you write HTML and you put your Rust code in curly brackets for the most part, and it works out pretty well, right? We also have a function-based builder syntax where you don't have to use this macro at all, and you just use functions, which works pretty well, but is not my cup of tea personally. Server functions, again, already introduced by the previous presenter. Leptos and Dioxys actually share this crate, this implementation. We work together fairly closely, and Leptos came up with this originally, Dioxys integrated it, and since then we've shared code and patches and stuff back and forth. Recently they gave us a very nice WebSockets implementation with a server function, so that got a lot easier as time has gone on. And yeah, so I'll talk a little bit more about server functions because I love server functions. They're one of my favorite things, right? This servo macro here will auto-generate basically a REST API endpoint, and it will also auto-generate code to call it in your components, right? So that not only do you get a type guarantee across the boundary, right? But I mostly don't have to worry about, say, if I was using GraphQL, converting to GraphQL and then back, or if I'm using TypeScript, writing a validator to make sure it's actually the correct type. Nope, you write this and you get the type for the most part. And I say that, yeah, so unfortunately, because there is a server and there is a browser and it's starting on the server and going to the browser, you do have to write kind of this code to handle what happens, say, when the page is loading or if the page fails or if it doesn't fetch, right? And you can kind of see what that looks like here. This is a little bit of the older style. We've updated this a little bit to be nicer. But basically, you call the function, you call get on the resource. It gets the resource. If it works, you get a count. If it fails, you get an error. And it puts it into your page, right? Pretty easy, I hope. Here's another server function. You can see some props. I think it's pretty straightforward. Someone will probably ask me a question later that makes me reconsider that, but it is what it is. We've tried to stay pretty close to the MPA style of web app. So basically, if you wanted to build your site so that you didn't need JavaScript at all, you can absolutely do that. And one of the ways that we do that here is with an action and an action form. So the action is basically the counterpart to the resource that we saw here. Resources mostly handle data loading. So if I wanted to get the name of the user on page load, that's a resource. If I want to hit submit to change that username, that's an action. But we just do a little cutoff there. But anyway, we just basically wrap a form element. So you call the action equals update count, and it's basically a form. You put in what the server function expects, you get back an OK or whatever you're expecting, right? Pretty painless. Routing has been pretty consistent across all the Leptos frameworks. It looks somewhat like this. Path equals, pretty boring. So now comes the more fun part from my perspective is to try to tempt you into using Rust on the full stack, or at least Rust on the front end and somewhat of Leptos. And we've certainly heard a lot of these things as I've attended conferences and as we move forward. The bundle size is too big, the startup time is too slow, it doesn't have direct DOM access, so it's terrible. Compiling takes too long. You can't get, something that JS provides or React provides. The community is too small, basically. And a lot of these are either mitigated and somewhat true or false. And we'll talk a little bit about those. Performance, the JS performance benchmark. Again, very small, so I'm sorry, you'll have to look at that later. But the point of this basically is that as far as rendering speed goes, Leptos is here, vanilla JS is here, and React is over there. So pretty good, right? 36 versus 43 milliseconds. We do fine, right? And that's with potentially a larger WebAssembly bundle size, right? Because if you remember from the last talk, you kind of have this 2x delta where WebAssembly will be compiled and run instantly as it's streamed, basically, and you kind of get away with some of these optimizations. So, compile time-wise, these are not clean. These are incremental compile times on some of the sites that you've seen: 5 seconds, 5 seconds, 2 seconds. You know, we've certainly
Recording in progress.
Okay. We've certainly gotten feedback on this, and some of it is built into Rust, right? Like, I'm not going to rewrite the Rust compiler to make it faster somehow. But then again, the Dioxys folk have been adding on to the Rust compiler to do hot binary patching. So I'm expecting this to go down even further. Their new thing is called subsecond, which we're talking with them about, but potentially this could go down even further, which is nice, I suppose. You know, if you're used to TypeScript and Vue and React, right, you pretty much get instantaneous feedback, as long as you don't call the TypeScript type checker too much. We also have hot reloading in a few different forms. Because we have a macro that takes in HTML, we can kind of do some neat tricks where if you change some bit of that HTML, we can detect, we can patch, for example, that HTML in your browser and then kind of recompile it in the background. And we have some of that stuff. It's built into our tool. Always fun. Another good reason to use Leptos is that you really care about performance. Some of this is just Rust on the web, but there's a pretty big difference in performance of a Rust stack versus, say, a Node.js stack. And some of this probably is a little bit exaggerated because the Node.js stack, which you'll see in a minute, is Express plus Remix. And Express isn't the fastest server I could have chosen. It's a common one. But so I put it on the same virtual CPUs. Details are here. OK, so I love this graph. Remix plus Express, you can kind of see as I threw more and more packets at it. This is requests per second here, and this is latency. So as this goes up, this starts at like 50 milliseconds, and then up here is 10 seconds. You can kind of see that about here, things get bad for the users, and about here, well, it starts to fail a lot. So that puts us at a request time, a number of requests that it could handle per second of about 200-ish requests per second. Just not terrible, right? But then you throw Leptos at it, which is a full Rust stack with Axum on the back end, Leptos on the front end. And now, over here, you can kind of see that these numbers have gotten a bit compressed, but you're looking at something like 1,000 requests per second, 1,200 requests per second, right? That is a pretty substantial infra cost decrease if you're paying for this and you're at that level of production, right? So big reasons there if you care about cost. If you don't care about cost, like me personally, I just like writing Rust, right? Writing Rust, for the most part, is enjoyable. It lets me get types across the boundary. It's got cargo and Rust analyzer and nice error messages. Like, a lot of that's very nice and convenient, and I want that in the future. So that's another good reason to pick Rust, is you enjoy writing it, right? I work at a company now called IDverse. IDverse does ID verification combined with facial recognition to prove that you're the person on the ID. And the reason I mention that here is because one of the reasons we chose this that I haven't listed is just security and stability and the type guarantees that it provides. For the most part, we've found that since converting our legacy app to a Rust-based app, we've seen a much increased throughput with a much decreased number of bugs, right? And we care a lot about that as a company that's supposed to prove that you are you painlessly, or at least as painlessly as possible. The front-end world has always been complicated. I can talk about why that is. It's probably us. But yeah, right. There's a lot of complexity in this space. The tools, as they grow, will get more complex, but I think we've covered most of the things that you would want to do here. The last fun thing that I like to talk about is developer time. So some of those commercial users we talked about, I've went out and asked them, hey, how did you enjoy writing Leptos and Rust? What was your experience like? And one of the things that surprised me is developer time. So one of the things that I hear a lot from JavaScript developers is, hey, iteration time, right? Like if I edit this page, I want to see the results instantly, right? I want, that whole extremely speedy iteration cycle. But we found that with Rust, because the type system and the Rust language itself can take some of that burden, people are actually writing more complex things in less time. It simplifies building and maintaining your code base and helps you keep your head on straight. So I've got a bunch of quotes here from different people, from the people most of them that you saw at the beginning or that I skipped. Since then, we've added a few more projects that are very large and I haven't gotten quotes from, which I should, which we can talk about afterwards. But basically, the decreased time in maintenance and the decreased time in bug fixing and bug remediation has paid off for them. Right? You can see that in a few different ways. Chris Biscardi here, which I won't, again, dawdle on. The California Beach Volleyball Association. I'm sure that's the most important quote here. You're all convinced now. We've got a pretty strong community. We've got a couple different component systems. We've got tie-ins with Tailwind and a whole bunch of other things in the space. We tie in with some of the JS packages, some of the editors and the maps and what have you. I would say generally that you can get most of what you want pretty easily, right? You may have to write some things by hand or write a wrapper around a JS1 for something, but for the most part, people seem fairly happy with our ecosystem and community. Yeah, so that kind of wraps it up. I'm going to, as we said, attempt is server functions, performance, infra costs, writing Rust, which hopefully I don't have to convince you of, and reduced developer time versus complexity graphs, right? You're welcome to join us. We have our Leptos website here, leptos.dev. A good example of what WebAssembly bundle sizes look like. I think we're at like 100 kilobytes or something like that. We've got a very active Discord and a GitHub that you can find by searching Leptos. Yeah, that's the end of the stuff that I have prepared. If anyone has any questions, love to talk.
Yeah, thank you very much, Ben. And there's one question. I come around with a microphone.
Sneak over here for a second.
Hi. You mentioned that you are very focused, or you made the decision in part because of security
Yes.
and stability.
Yes.
Now, in the previous talk, Gert said that he wouldn't use at least Dioxys full stack for the actual full stack because of things like authentication. So I just wanted to ask how Leptos fares in this space and what it has, what it doesn't.
Sure. I mean, I'm thinking about how to say this in the best diplomatic way. So security-wise, I think the biggest thing that you're looking for is input validation on whatever the client is doing, and then you're looking to make sure that some things that you're doing on the server only happen on the server, right? Your client keys are over there and not being sent down. And for the most part, let me see if I find...
Also things like permissions, access controls.
Access controls, right, exactly. Like, Server functions here are called server functions because when this macro runs, this stuff in here compiles on the server, but it also builds it for the client, but there's nothing in here. It's just the call to the server, right? So anything that lives in a server function never leaves the server, and is a good place to put a lot of these things that might be security conscious. As for access control, I actually gonna have a use. This routing here, I don't have an example of it, but you can use a protected route and gate that behind one of the server functions, getting the user's token or ID or what have you. We've got crates built in for SSO and OAuth and JWT and all of those things. I can't really think of a great reason why you wouldn't do it for security reasons. That being said, I would not recommend a client-side app. You can build those with Leptos, but then everything gets sent down. So as long as you avoid that, probably be okay. So we're absolutely happy with the state of that in our code bases. Earlier last week, I was talking to Amazon. They've built their dashboard for some SQL-based database thing that they've announced last week in Leptos proper. So, like most things, I guess it's in the hands of the developers who build it, right?
Kira, can you hear us? Maybe let's take a question online.
Not see anything in the chat just yet. Some praise for the good tutorials and videos on your website, though. People are happy with those.
Thank you.
I had one question is, you mentioned Amazon, and I was at the Rust Global talk where the person from Amazon was talking about that they also have an additional kind of in-house framework super inspired by Leptos. Has there been any sense of them feeding back any of that aspect of development into Leptos, or are they fully forked?
I have not heard about that directly. My experience with big corps, big tech basically, is that if they use open source in this way, and it's not terribly complex, they will often just rewrite it and then use their own internal thing forever. You see that with things like Git, right? They've all got their own Git thing instead of trying to do that. I was also talking to Netflix, I think that was last year. They based some of their UI on our signals system, our state system. And then instead of submitting patches, they forked and rewrote part of it and then put it on their stuff. So, you know, we can hope.
Okay, Timo has a question.
I think WebAssembly cannot call into web APIs directly. Do you know how much overhead there is when you have like a burst of hundreds of requests into some web APIs?
Right, so that's a good question. How much delay is there into JS depending on that, right? You can talk about that a few different ways. There is the overhead of converting it into, I think it's i32s or i64s or i8s, whatever WebAssembly actually supports. And there's been a few ways around that. I'm looking for that slide with the green and red on it. Apparently, yes, okay. This is with those calls, right? This is comparing all of the calls to the DOM to build your page versus native calls of the DOM to the page. So for the most part, we get along just fine. If you are going to be doing like bulk image processing, I wouldn't recommend you directly call it. I'd probably recommend like a shared buffer system where you can share the memory between WebAssembly and JS and interop through that. For the most part, we haven't found that as a problem. There's also one here, which I did include, Leptos Sledgehammer, which basically tries to do something where it batches all those calls into kind of one. But functionally, the performance difference for us has been almost negligible for a bit more complexity, so we haven't bothered. I believe Dioxys did find a bigger benefit on our using that. So.
Okay. Do we have more questions?
Got one online, two online. So one is, are these slides available? Will they be shared somewhere after the fact?
Well, that's a good question for Tim. I don't mind if you share the slides.
We can come up with something, I guess. We will find a solution for that.
At the very least, we'll put it on GitHub somewhere.
Yeah.
So.
We've got a second question from Leonie. They're wondering if in Leptos and Leptos Axum, use of from-ref substates has been tested with using Leptos Axum file and error handle in the Axum router fallback. It's documented to work, but it seemed like Type-inference was broken. Is this a known issue? It's a very specific question.
That is a very specific question. I do believe earlier today I looked at somebody who told me that it did work, but there was an inner function that's not public, so they kind of had to copy-paste it. The answer generally is yes. We build on top of Axum or Actix or Cloudflare or Fastly, or there's a whole bunch of those, right? It should work fine. If you're having an issue, feel free to open something in our help section of our Discord or GitHub issues, and we'll take a look. But I also modify that handler to do some things, and it's worked for me. So,
Thank you.
one of the nice things about Leptos that I'll briefly tack on here is that it can absolutely live alongside your existing Axum app or your existing Actix app, right? You can define Axum routes, if you know how to do that, and then call them from Leptos, right? We're not trying to be exclusionary or keeping one thing away from another. We integrate with these things as best we can.
Yeah, very well. I don't see any more questions here.
Great.
So I would say thank you very much, Ben. A lot of applause.